So this is a problem going over a piecewise defined function for f of x. So f of x will take on three different functions, but the important thing is to note the boundaries, boundary conditions for each function. So y, or f of x, will equal 5 times x, as long as x is greater than or equal to -6, but strictly less than 1. So, okay, with those boundary points, kind of having my graph here, several points might be hard to plot. So say for f of x, if I let x equal -1, since it's a boundary value, it's supposed to be -1 there. So 5 times -1 would be -5. And I can plot that point here. Out right there. Sorry if the focus goes in and out a little bit. Okay, how about -2 for x? So 5 times -2, that's -10. And as you can see on my graph here, that's going to be a little bit over. So I'm plotting those points. So in essence, 5x is a straight line or linear going up. Okay, it has to be strictly less than -1, so I should have an open circle here. So sorry for plotting that point, but that is a boundary value. But since x is strictly less than -1, open circle. Okay, the next function. This time, if x is greater than or equal to -1, but strictly less than 0, we have a constant function, y, or f of x, is equal to -5. So that's your horizontal line going right across at -5. So, well, in that case, you're going to have a shared point right here of the open circle, so that will become a solid circle. And just going right to the axis right there at -5. Okay, but it has to be strictly less than 0. Noting that, but now going to the third function, which is a parabola that opens upward, and the vertex is shifted down 5 units. So we just do x squared, a parabola. So if I plot some points, again between 0 and 3, if I let, oops, forgot to label my table values there. If x is 0, 0 squared is 0.